In lesson 0.1, we're looking at function operations and evaluating operations. So you're going to see f of x, and that means the function of x. So in this first example, we're asked to evaluate the function at the given value. So what that means, we're trying to find what f of 5 is. So everywhere where we see x, we're going to replace it with a 5. Now, it is really important that when you are replacing x with that number, you want to use parentheses. So notice I put that 5 in parentheses. And then we can go ahead and evaluate what that would be. 5 plus 4. 25 plus 4 is 29. So f of 5 equals 29. So b greater than g of x equals 4x plus 8 over 2x minus 5. And we want to evaluate what g of negative 2 is. G of negative 2 equals 4 parentheses negative 2 plus 8 over 2 parentheses negative 2 minus 5. So 4 times negative 2 is negative 8 plus 8 over negative 4 minus 5. So then we get 0 over negative 9, which is 0. So g of negative 2 equals 0. Okay. I suggest you pause and try this third example for yourself. So k of 3 equals 4 square root of 6 times 3 plus 2. So 4 square root 6 times 3 is 18 plus 2. 4 square root of 20. Now, if we were to plug that in our calculator, we would get 4. The square root of 20 is 2. Square root of 5. We multiply our 4 and 2. And that gets us 8 square root of 5. K of 3 equals 8 square root of 5. So that's how we evaluate with a number. Now sometimes you're going to be asked to evaluate the function given an expression. So f of x equals 8. Now once again, we still have to put that in parentheses. So then I would see if I could simplify. So 8x plus 16. So f of x plus 2 equals 8x plus 16. Right, we have g of x minus 4 equals x minus 4. We're replacing x with that expression and squaring it. So x minus 4 times x minus 4, we get x squared minus 4x minus 4x plus 16. So combine like terms and we get g of x minus 4 equals x squared. I can combine those to make negative 8x plus 16. Okay, this last example, once again, I challenge you to pause it and try it for yourself. So d of 2x plus 3 equals negative 5. 2x plus 3 plus 4. Now we need to distribute that negative 5. So we get negative 10x minus 15 plus 4. Combine like terms, negative 10x minus 9. So d of 2x plus 3 equals negative 10x minus 9. Now, that is our evaluating functions. Now, these are our function operations. So, I suggest you write this in your notebook. So when we have addition, we'll see f plus g of x. And really what that means is we're going to add f of x plus g of x. Now subtraction, we'll see f minus g of x, and that means we're going to subtract f of x minus g of x. Multiplication, f times g, so that means we're going to take f of x times g of x. And then division, f over g means f of x over g of x. Now you need to pay attention to the order, because if your f and g are switched, then your order switches. So here is an example. We have f of x is 5x plus 2, and g of x is negative 3x plus 7. So I'm going to replace f of x with 5x plus 2 plus g of x negative 3x plus 7. And then I'm just going to add these two binomials. 5x plus negative 3x is 2x. And then 2 plus 7 is 9. And that's our new expression. Then we have multiplication. So I'm going to take 5x plus 2 times negative 3x plus 7. So 5x times negative 3x, negative 15x, 5x times 7, 35x, 2 times negative 3x, negative 6x, and 2 times 7 plus 14. Combine, oh, oops, and that should have been negative 15x squared. So negative 15x squared, make sure you don't miss that like I did. Now we can combine 35x minus 6x, which would be positive 29x plus 14. And you want to make sure these are in standard form, largest exponent to smallest. Now remember, f minus g of x means f of x minus g of x. So we're taking 5x plus 2 minus negative 3x plus 7. Now this is where, if we change this middle subtraction sign to an addition, every sign after that has to change. So now we're doing 5x plus 3x, which is 8x. Doing 2 plus negative 7, which is negative 5. And now we have one last one, our division. So remember, this means f of x over g of x, which is going to equal 5x plus 2 over negative 3x plus 7. Now this we can't simplify any further, so that's what we have. So there's one last thing that we're going to see in lesson 0.1, which is domain. So just a reminder of what domain is. It's the set of all possible x values which will make the function work and will output real y values. When finding the domain, remember, now this is super important, the denominator or bottom of a fraction cannot be 0. And this is called undefined. So example 4 says at what x value is x plus 5 over x plus 2 undefined? So what it wants to know is when will that denominator equal 0? So if we were to solve this for x, we would get when x equals negative 2. So that means for our domain, x can be anything but negative 2 because we can't have a 0 in our denominator. So what x value is not in the domain of 5x plus 9 over 5 minus x? So exact same thing, set that denominator equal to 0 and solve for x. So I subtracted 5 from both sides. Now I need to divide by a negative. So x equals positive 5. That is when our denominator would be 0. So that means 5 is not in the domain.